In a geometric progression, the third term is 16 and the fifth term is 4. Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. This is third video on geometric progression, and here is the question. So we have a third term, which is 16, and fifth term, which is 4. So we are going to come up with equations out of what is given, so that we solve for our first term and the common ratio. So we know that any term of a GP is equal to a at the power n minus 1. Now here we have third term. So you say third term is equal to a r. In this case n is 3. So 3 minus 1, you get 2. So third term is equal to ar squared. And here we can see the third term is 16, meaning ar squared is equal to 16. So this is going to be our equation 1. Okay, then we have our fifth term. So fifth term is equal to ar to the power, so n is 5, so 5 minus 1, you get 4. So ar to the power 4. Again here we say ar to the power 4 is equal to 4. And this is going to be our equation 2. Okay, so we are going to solve these two equations simultaneously, so that we have the value for a, which is first term, and the value for r, which is common ratio. Okay, so here it's just a matter of dividing the two equations, so that we cancel out the a's, so that we remain with just r. We can see that in equation 2, the power for r is 4, and in equation 1, the power of r is 2. So equation 2 has the highest power of r. So we can divide equation 2 by equation 1. So in equation 2, we have ar to the power 4. So this is divided by, in equation 1, we have ar squared. So this is equal to, ar to the power 4 is equal to 4. So 4 over ar squared is equal to 16. So over 16. Okay. Then here, we can see that a and a will cancel out. Then we're going to remain with r to the power 4 divided by r squared. So here, since the bases are the same, you can just subtract the powers. So 4 minus 2, you get 2. So here, we are going to have r to the power 2, that is r squared, equal to, here we can simplify the fraction. We have 4 over 16. So what is the highest common factor for 4 and 16? Yes, 4. 4 in 4, 1. 4 in 16, you get 4. Now, we are not solving for r squared, but we want to solve for r. So here, we need to cancel out that power 2, the squared. What's the reciprocal of squared? So the reciprocal of squared is square root. So we are going to square root both sides. So square root this side and square root this side. So r is equal to, we know that the square root of 1 over 4 will be, square root of 1 is 1, square root of 4 is 2. So r is equal to 1 over 2. Then we can solve for a, either using equation 1 or equation 2. Where there is r, we are going to put 1 over 2. Okay, let us use equation 1. So in equation 1, we have a, r is 1 over 2 squared equal to 16. Okay, so here 1 squared is 1 times a, you get a, over 2 squared is 4 equal to 16. Okay, so since here we have a fraction, even this side it can be a fraction, so you say over 1. Then we can cross multiply. You say a multiplied by 1, you get a, equal to 16 multiplied by 4, you get 64. Okay, so a is equal to 64 and r is equal to 1 over 2. So therefore, our first term is 64 and common ratio is 1 over 2. So we have answered the first question. Okay, we go to the next one. So the next one is the 10th term. 10th term. Okay, this one is so simple. Nth term of a GP is equal to AR to the power n minus 1. So 10th term. Our 10th term is equal to A is our first term. And first term is 64. So we have 64 multiplied by our common ratio. It's 1 over 2. Then to the power n minus 1. We know that we are solving for our 10th term. So n is 10. So 10 minus 1, you get 9. Okay, so 10th term is equal to, we can use a calculator here. So we'll say that is 64 times, open bracket, 1 over 2 to the power 9. Okay, so that is 1 over 8. So the 10th term is 1 over 8. Okay, that is the second question. The third question, the sum to infinity. This one is also simple. Here is the formula. A sum to infinity, that is S sub infinity, is equal to A over 1 minus R. So that is the formula for calculating sum to infinity of a GP. It's as A over 1 minus R. Okay, so sum to infinity is equal to A is our first term, and you know that it's 64. So we have 64 over 1 minus R is 1 over 2. So 1 minus 1 over 2. Okay, so sum to infinity is equal to 64. Here we say divide by 1 minus 1 over 2. This is 2 multiplied by 1 is 2, minus 1, that is 1, then over 2. So 1 minus 1 over 2 is just 1 over 2. Okay, and we know that when we are dividing fractions, we change to multiplication. And when we change to multiplication, the fraction this side will interchange, will swap. The denominator will become the numerator, and the numerator will become the denominator. So we have sum to infinity is equal to 64 times 2 over 1. And we know that 2 over 1 is just 2. Okay, so what is 64 multiplied by 2? Yes, 128. So sum to infinity, you get 128. Okay, so this is how you perform calculations involving geometric progression. Thank you so much for your time.